Okay, so performance tuning, right? Sparks performance tuning. This is one question, regardless of your experience, you will be asked this question. So, what are the performance tuning techniques that you have done, or what are the performance techniques that you are aware of? Okay, so we need expect these questions, guys, all the time. Okay, so basically performance tuning, right? So before we get into details of the different techniques in the performance tunings, we need to understand why the jobs become slow, why the performance degrades, right? So you need to understand that first. Okay, so there are different the reasons why the Spark performance will degrade. So if there is too much of data movement, right? So too much of data movement, basically data shuffling, correct? So why this is like, if you have data shuffling, you need to move this data from one place to one other, so that input output operations happens, that will cost us, right? So that is why it is one of those reasons why we end up having a performance issue. Okay, and poor memory usage. So if you have memory, if you're not utilizing it, or if you're overutilizing it, again we'll see that, then you will end up with the performance issues. So let's say you have like memory and you're using 99% of the memory into one operations, then the other operations will slow down, right? Bad partitioning. So bad partitioning would be like, if you have too many partitioning or too little partitioning, then that will also be a cause for your performance degrade. Like for example, if you are having like a 100 partitions and each partition is like 2 MB or 3 MB, so you are basically generating too many small files in HDFS, which is not a good thing. That will cause a performance issue. And if you are using a wrong join, right, the wrong strategy, so you have different joint strategies here. If you're using some wrong joint strategy, like if you're not using broadcast where you're supposed to use broadcast, and those things can also come up into the performance issue. And of course, and another important thing is inefficient file formats. Okay, so if it is very important for you to choose the right file format. If you're not choosing the right format, then that will also cause the performance issue. So what can be done to actually avoid these performance issues, right? So we need to understand, we have understood the cause, right? So what causes the performance issue? So what should be our goal in order to increase the performance? So we should reduce the input output operations. That means reading and writing less data from the disk, right? Less reading and write from the disk. So this will ensure that the performance is not degraded. So this is reduce. Okay. Uh, Shuffling, of course, you need to reduce the shuffling, the data movement from one node to another. You need to reduce the shuffling. Memory usage also you need to reduce. So if you don't use the 100% of the memory, you always need to put some sort of memory here to ensure that we avoid the memory spills or out of memory errors. So you will see this out of memory error issues happening in the production environment, all the stuff. So you need to reduce that. You need to ensure that you increase the parallelism, but effectively. So do not use as many nodes, as much of parallelism as you want. So again, use the CPUs efficiently, right? So that is an important thing. Recomputation. So you need to reduce the recomputation. So how you can reduce the recomputation? So you could use coalesce, you could use repartitioning, you could basically cache the data, right? So these are some of the things that you could use to kind of like reduce the increase the performance. Okay. Now let's look at some ways how you can these are basically the goals, right? Now let's look at the each of this in detail. Okay, so the right file format. Okay, so we need to use the right file format. So why it matters? So Spark is fast when we are working with the columnar storage formats. So if you have a columnar storage format, then Spark performance will be very fast. So if you're using something like CSV, the performance will be very slow. Uh, if you're using JSON, it will be slow. If you're using something like Spark or ORC, your performance will be very fast. So a lot of times we end up using the Parquet. Again, there might be scenarios where you have to use the JSON if the data is coming in that format. That is fine. But unless if you have a choice, always prefer to go with a columnar storage, either Parquet or ORC. So this reduces the input-output disk, network traffic, memory usage, and it also, this is a column-based storage, right? So it has that built-in compression, and if a predicate push on, it reads all the required columns only. So these are some of the advantage that you have if you are using the columnar storage, which is Parquet or ORC, right? So next, memory tuning, right? So we talked about one of the goals, right? We need to have right memory tuning. So Spark uses memory for different cases, like for caching the data, for shuffling, aggregations, joins, right? So for all these things, Spark uses the memory. Okay, so you need to configure your nodes executors. So there are certain configurations that you need to do. Spark dot executor dot memory. This is one. Then there is Spark dot executor dot memory overhead. So these are some of the configurations that you need to do. Spark.driver.memory. So you need to have the optimum configurations here. So proper memory tuning, right? So this will avoid out of memory errors, disk space, and execution speed will be improved. So typically these are something which is already set up in your production environment. You don't have to worry about it. So this is like trial and tested memory depending upon your cluster size and everything. So this memory tunings can be done. So mostly you don't have to do it. Again, there are certain cases where the developers have to do it, but otherwise it's something, if you have a production team ready, they will take care of that. But you need to know the concept here. Okay, you should be using cache and persist because when the same data set is being used again and again, you need to cache it. So you will have to use the cache and persist to ensure that you are storing this data in memory and you are not recomputing it, right? So one of the things that we saw, like recomputing takes a lot of time, right? So because you're doing the same thing again and again. So once you have already done it, just cache it so that that is available. You don't have to recompute it. So you don't have to reread it from the disk. You don't have to recompute it. So you already done it. You just utilize it. Okay. So that's one thing. Then we also have something called as coalesce and repartitioning. Again, we talked about the efficient utilization of partitions, right? So you need to ensure that you have right amount of partitions. So why? Because if the partitions are sized badly, then it will be cause an issue. Like if you have too many partitions, right? If you have too many partitions, then it's an overhead. At the same time, if you have too little partitions, then most of your nodes or your CPU are actually sitting idle. That is also not good. So again, you need to ensure that you use coalesce and repartitioning to optimize the partition. So use the repartitioning if you want to rebalance the data using shuffle. Use a coalesce if you want to merge partitions without shuffle. Like if you have too many files, too many small files, then you can use coalesce to kind of merge them into smaller into less files so that the performance will be improved. So repartitioning, as I mentioned, for load balancing, coalesce for reducing the output files. Okay. And of course, we need to also ensure that you use the right join. So that join optimization is another important thing that we need to do. what join, what is the right strategy, right? That is also matters. So you need to use the, if broadcast join is a possibility, please use that broadcast join. So this will avoid the shuffling, the network transfer, all these things. Then, if possible, you also have to use the serialized data. So, serialized data, Spark sends data between driver and executors, right? So, using efficient serialization, it reduces the memory footprint, it speeds up the network. So, the serialized data moves much faster than an unserialized data. So, there are different serialized data, like for example, Cairo serialization, right? So, this is a very efficient and fast the serialization. Okay, so uh, that is one approach that you can take. Partitioning. Again, we talked about partitioning, right? So good partitioning. Make sure all the CPUs are busy, right? So these are some of the things that you can try to ensure that you are using sorry, you're using the right techniques and everything. One very basic thing is the filtering, right? So if this is one important concept, you need to filter as close to the source as possible. So let's say you have a lot of records, let's say 1 TB records, and you want to do some processing on it. Now, the question that you should ask is like, do I have to do the processing on all the 1 TB data records? Or are there some records which can be filtered? If there are, for example, this 1 TB data might contain data related to US and India, and you only wanted to do the process on US data. So instead of doing all the computation for both US and India and then filter it, you need to kind of first filter it. So do the filtering as close as possible so that you are eliminating all the records that you don't have to actually reprocess or recompute or compute, right? So that is one basic thing, and it is same for any technology, whatever, if you're using SQL, Informatica, whatever it is, ensure that you filter it as close to the source as possible. So these are the basics, or these are the some of the techniques that you can use to kind of uh, improve the performance. So very important to first understand why the performance degrades, what causes the performance, and then based on it, you have different ways how you can improve the performance. All right. So that's all here, and I'll see you guys again in my next session.